Hello everyone, this is Miss Chelsea and today we'll be learning to balance chemical reactions. Our question of the day is, what is the difference between a coefficient and a subscript? Today our standard is SC3A. Use mathematics and computational thinking to balance chemical reactions and construct an explanation for the outcome of simple chemical reaction based on the outermost electron states in the atom, trends in the periodic table, and knowledge of the patterns of chemical properties. In order to balance chemical equations, we need to think about the law of conservation of matter. Keep in mind, we can only change the coefficients, which will change the number of molecules or moles of the substance, but we cannot change the subscripts, which would change the substance itself. So changing H2O into H2O2 for the sake of balancing would turn water into hydrogen peroxide and therefore change the reaction itself. That's why it's not allowed. The law of conservation also tells us that we need a balanced chemical equation, or a chemical equation with the same number of each type of atom or each element on both sides. So we know that the reaction below is not balanced because we have one less oxygen atom on the right than the left. It looks like oxygen is being destroyed. So an easy way to balance equations is to draw a vertical line on both sides of the arrow to separate your products and reactants. We're going to list all the elements in the equation below these two vertical lines. If you have a polyatomic ion that does not get decomposed or altered in any way, you can write the entire polyatomic ion between the vertical lines. However, if it gets broken up into its parts, then you cannot. Then we're going to count how many atoms of each element you have on both sides of the equation, and finally alter our coefficients and keep updating the chart below the equation until you have the same number of atoms of each element on each side of the equation. Let's look at an example. Here we have hydrogen and oxygen combining to form water. For step 1, we're going to draw our vertical lines. Step 2, we're going to add our elements. So all the elements in the equation, in this case hydrogen and oxygen. Then we're going to count how many of each element we have. So H2 means 2 hydrogens, O2 means 2 oxygens, and H2O means 2 hydrogens and 1 oxygen. Finally, we're going to try to balance. So here I notice we don't have enough oxygen on the right, so we're going to make that 2 waters on the right, and we're going to update our chart to have 4 hydrogens because 2 times 2 is 4, and 2 oxygens because 2 times 1 is 2. However, our equation is now unbalanced in the other direction. We don't have enough hydrogens on the left, so we're going to make that 2 hydrogen molecules and update our chart. And as you can see, we now have 4 hydrogens on both sides, 2 oxygens on both sides, and our chemical reaction is considered balanced. Remember, if no coefficient is written, there is an imaginary 1, just like in math.